Welcome back, grade 6. Today we're working on Nelson Math, chapter 13, section 6, comparing experimental and theoretical probability. We spent a lot of time already looking at each of these separately. When we look at the experimental, running the experiments with either number cubes or coins or spinners, and we spent the last couple of days looking at theoretical probability, which is coming up with all of the possible outcomes and seeing how likely each one of them would be to come up. Here's the problem we're facing today. I have two four-sided number cubes. Compare the theoretical and experimental probability of rolling a difference of exactly 2. So the difference of 2, when you take the larger number and you subtract the smaller number, it should be 2. I've already gone ahead and pre-populated all of our tree diagram sections. So the first number here at the stem, that would be the number on the first four-sided cube. I want to point out it's a different kind of a cube. It's a cube that only has 4 faces. So we are only going to have 1, 2, 3, and 4 on each cube. Not the typical standard 6-sided. It's 4. So this tree diagram right here showing a 1 on the first cube, and this branch is showing a 1 on the second cube. This 2 here represents a 1 on the first cube and a 2 on the second cube. This one's a 1 on the first cube, a 3 on the second cube, a 1 on the first cube, a 4 on the second cube. And here I've listed the outcomes as pairs. So 1, 1, 1, 2, 1, 3, 1, 4. And here I've listed the difference. The difference between 1 and 1 is, of course, 0. 2 minus 1 is 1, 3 minus 1 is 2, and 4 minus 1 is 3. That's where these numbers come from. I've done this exact same thing for each of the other 3 tree diagrams. So this one is 2, 1. The outcome is 2, 1, and the difference is 1. So we can see that from here. And I've gone ahead and filled in the rest. Here are the 4 different outcomes, and only one of them has a difference of 2. And here we have the first cube being 3, the second cube being 1, the first cube being 3, second cube being 2. And here are all of those outcomes where the first cube has a roll of 3. Here's the fourth cube, or our fourth tree, and we have our first cube with a roll of 4, and second cube with a roll of 1. Here are our 4 outcomes. Beside, I've listed all of the differences. Out of all of these, we have exactly 1, 2, 3, and 4 outcomes of exactly 2. So our theoretical probability of having a difference of exactly 2 would be 4 over 16. I've written that right here. 4 outcomes have exactly a difference of 2 out of 16 total outcomes. 4/16, I can rewrite that as an equivalent fraction as 1 over 4, or 1/4. As a percentage, it would be 25%. Those are all equivalent. So this is how we could show the theoretical probability with a tree diagram. However, we can also use one of these. So this is an organized list, and we're going to show all of our differences, assuming that this is cube 1 here. This would be cube 1. This would be cube 2. So if both of the cubes have a face showing of 1, the difference would be 0. And I'm going to fill in the rest of the chart now. The entire chart has now been filled in. So for example, if we roll a 2 on both of our number cubes, we get a difference of 0. If we roll a 2 on our first number cube and a 3 on our second number cube, we end up with a difference of 1. Now, highlighting all of the differences of 2, which are here, we see, once again, we have exactly 4, where the difference is exactly 2. And this agrees with what we did with our tree diagram. 4 outcomes out of a possible 16 outcomes are showing a difference of exactly 2. So that's 1/4 of our outcomes, or 25%. Both of these systems, as expected, would give the probability of getting a difference of exactly 2 at 25%. What I've also done is I've used one of our web pages from before. This is the one with the number cubes, where you can have as many different roles with as many different number cubes as you like. I've done 20 trials. So I did this 20 times to run my experiment 20 different times, and this is what was the result. My first trial, I had a 3 and a 1. So the difference was 2, as you could see from this part right here. My second trial, I rolled a 2 and a 6, so my difference was 4. I've done this 20 different times. Let's look at our 20th one here. I rolled a 1 and a 2, the difference being 1. We're now going to count how many 2s came up. We had 1 here, 2, 3, 4. So we had 4 different outcomes in our experimental probability trials, 4 different ones out of a total number of 20. And I've written that down here. So 4 of our total outcomes had a difference of exactly 2, whereas we had a total of 20 different outcomes. If we make that into lowest terms, these are equivalent: 4/20, or 4/20ths, and 1/5. Those are equivalent, which we can also write as a percent, which is 20%. So the numbers are close, but they're not exact. Our experimental probability for this particular experiment, this particular set of trials, was 20%, whereas for our theoretical probability, our probability was 20%. So they're quite close, but not exact. It is, however, what we might have expected because they are so close. Thank you, grade 6. Have a great day.